Okay, so we're on page 739, looking at topic 11.3. Problem number 2. A die is rolled. Find the probability that an odd or an even number occurs. So here's a die. And I roll it, and I could get what? 6, 5, 4, 3, 2, 1. Right? Those are the only numbers I could possibly get. And they want to know for problem 2 on page 739, what's the probability that I get an odd? That would be 1, 3, 5, or an even 2, 4, 6. So out of possible outcomes, I have 6, and desired outcomes, I have 1, 2, 3, 4, 5, 6. 6. So what's the probability of getting an odd or an even number? 6 over 6 would be
100%.
1,
Yeah.
or 100% of the time. Well, that was easy enough. Are they all going to be that easy? Look at number 1. A die is rolled. What's the probability that the number that comes up is 0? I look at my possible outcomes, and what do I say?
It's not possible.
0. Number 3, 2 dice are rolled. Oh, now we're rolling 2 dice. Maybe number 4 has you rolling 2 dice too. No? 2 dice are rolled. So that means you roll 1, and then you get, where's my eraser? Here it is. And you get 6, 5, 4, 3, 2, 1. Let me put them over here like this. 6, 5, 4, 3, 2, 1. And then with the second die, this is the first one. And then with the second one, you could have 6, 5, 4, 3, 2, 1, 6, 6, 5, 4, 3, 2, 1, 6, 5, 4, 3, 2, 1, 6, 5, 4, 3, 2, 1, 6, 5, 4, 3, 2, 1, 6, 5, 4, 3, 2, 1. See what I'm doing? Listing all the possibilities. And out of all the possibilities, 6 times 6 would be, the possible outcomes are 36. You see that? The desired outcome, what's the desired outcome for number 3? The sum of the two numbers is between 0 and 13. So let's see. Between 0 and 13. Between 0 and 13. 5 and 6 is what? 10, 9, 8, 7, 6. Is that going to be true for all of them? 10, 9, 8, 7, 6, 10, 9, 8, 7, 6, 10, 9, 8, 7, 6. So what's the probability of getting a sum between 0 and 13?
100%.
100%. You follow that?
I think so.
Because if the first one is, if the first one's a 6, I forgot to do that one. 6 times 6 is 12, 11, 10, 9, 8, 7. And then this is 10, 9, 8, 7, 6, 5. See what I'm doing? Adding these two together. 6 and 6, 6 and 5, 6 and 4, 6 and 3, 6 and 2, 6 and 1. and then 9, 8, 7, 6, 5, 4, and 8, 7, 6, 5, 4, 3, and 7, 6, 5, 4, 3, 2. So those are all the sums. So between 0 and 13. Will all of these fall between 0 and 13?
So what do you write above on the fraction over there for desired outcome?
So that would be 36. 6, 6, 6, 6, 6, 6.
Is there a way to figure that out without having to write it all out?
Without drawing a picture? Let's
Well,
see.
You can't. Wait.
Okay, if I want the sum of the numbers between 0 and 13, when I add 2 dice, what's the largest number I would get?
12.
6 plus 6 is 12. What's the smallest number I would get?
2.
1 plus 1 is 2. Does that help?
Yeah.
So all the numbers are going to be between 0 and 13.
Okay.
You don't like making those trees.
No.
No, they just look too messy. Problem number 4, an absent-minded professor wants to mail 3 report cards to 3 students, and she addressed 3 envelopes, or envelopes, depending on how you were taught to say it. If it's envelope, then why isn't it oven when it's spelled E-V-E-N? Seems to me like envelope sounds better. She did what? She mailed 3 envelopes. Envelope 1, envelope 2, envelope 3. I know you don't like these trees, Carissa, but we're going to do another one anyway. Maybe if we do enough of them, you'll learn to like them. So she's got 3 envelopes, and she has 3 report cards. So in envelope 1, she could put card 1, card 2, or card 3. Card 1, card 2, or card 3. You see that? Card 1, card 2, or card 3. Now, if she puts card 1 in envelope 1, she's got a match, so she's got the right card in the right envelope. You follow that? And if she puts card 2 here, she's got a match. But what is the question asking us? What's the probability that exactly 2 students get their cards? So exactly 2, that would be this one and this one. Get their card, and this one doesn't. Well, if we've already used 2 and 3, which one do we have to use for this envelope? 1. That's all that's left to use, isn't it?
So they'd get it too.
So if I have 2 of them right, then what is that going to result in? The other one's going to be right too. So I'm either going to have all 3 of them right, or 1 right and 2 wrong. So what's the probability of having exactly 2 of them get their cards? If it's either 3 or 1, then it can't be exactly 2. So if this is not possible, then what's the probability of something happening that's not possible?
0.
0. over 9.
So it's not possible for two of them to get their report card back.
If this guy gets his report card 3 and 3 and 2 and 2, what's left to send it, put in this envelope?
There's 1 and 1.
So that would be a match.
Yeah.
So that means all 3 would match. And they said
Oh, that
exactly
two.
2.
Not at least 2. That's different. Okay.
Why do they ask these trick questions? All right. For problems 5 through 8, we're using a container with 10 little numbered balls in them, and they're numbered 1 through 10. Number 6. So now, I've got these little balls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that right? And I'll just circle them. So you can see we've got little round balls we're pulling out of an urn. And so we have how many possibilities? 10. And what's my desired outcome for number 6?
An odd numbered ball or a ball with a number less than 5.
Odd would be what? 1, 3, 5, 7, 9. Or what's the other possibility? Or what?
Number less than 5.
Or less than 5. That would be 4, 3, 2, 1. Agreed? So now what's the probability? What's the desired outcome? 1, 2, 3, 4, 5, 6, 7 out of 10. Now for those who don't want to draw a little picture, the probability of A union B, that's OR, okay? What page is that on? Page 736. Is the probability of A plus the probability of B minus the probability of A intersect B. So what's the probability of A? Odd number, 1, 3, 5, 7, 9, 3, 4, 5 over 10, plus the probability of B, a number less than 4, 1, 2, 3 over 10. Everybody see that? Then minus the ones that overlap, that would be this one and this one, minus 2 over 10. Out of 10 plus 3 out of 10 minus 2 out of 10. What did they say? Less than 5. So that's 4, 3, 2, 1. So I have minus 3 of them that double up. No, 4 doesn't double up. Four, 3, 2, 1. So that means less than 5, that's 4 out of 10 there, and minus 2 out of 10. The ones that are doubling up. Well, less than 5 would be here. 1, 2, 3, 4 out of 10. Odd would be here, 1, 2, 3, 4, 5 out of 10. And the duplicates would be 2 out of 10. And 5 out of 10 plus 4 out of 10, 9 out of 10 minus 2 out of 10 equals 7 out of 10. So you can use that formula, or you can just say, hey, I can draw a picture and identify the odd ones, and then the ones less than 5, 4, 3, 2, 1, and then recognize that 2 of them are duplicates. It's just your choice as to how you want to work through those. Problem number 8, a ball with a number that's greater than 7. So that would be greater than 7 would be 8, 9, or 10. Agreed?
Mm-hmm.
And what's the other one? Or what? Less than 5. Less than 5 would be 4, 3, 2, 1. So I have 3 here and 4 here. So that again would be 7 out of 10. And if you were using the formula, it would be 3 out of 10 plus 4 out of 10 minus, where do they intersect? 0 out of 10. They don't overlap. They don't intersect. Number 10, in problems 9 through 13, a single card is drawn from a deck of 52 cards. Find the probability that the card chosen is the ace of hearts or an ace. So I have, what do I have here with these cards now? I have 4 aces.
Mm-hmm.
And one of them is the ace of hearts, right?
Mm-hmm.
So, since they're saying probability out of how many possible outcomes?
52.
52. How many would be my desired outcome?
4.
4.
Yes. Okay.
Does that make sense?
Mm-hmm.
You see how it kind of helps to draw a little picture
Mm-hmm.
of what you're looking at here? Number 12. The ace of clubs or a black card. How many black cards? $26. The ace of clubs, one of those. But isn't that one of those black cards? Are clubs black? Hearts and diamonds are red,
Mm-hmm.
and spades and clubs are black.
Mm-hmm.
So you might put that information in your notes, so when they ask you a question about cards on the test, you'll have that information handy. So what would that be? Out of 52?
26 over
26, right?
Mm-hmm.
Because the ace of clubs is one of these black cards. Now, if you were doing the formula, you would say black cards would be, or which way did they say it? The ace of clubs or a black card. So the ace of clubs, that would be 1 over 52 plus a black card, 26 over 52, minus the intersection, which would be 1 over 52. See what happens if you're using that formula?
Mhm.
So you end up with 26 over 52. Number 14. The Weather Service reports that in a certain northern city it rains 40 days and snows 50 days in the winter. But it rains and snows only 10 days. Based on this information, what's the probability that it will rain or snow? So rain or snow, that's this here. So that would be the probability of rain, which is what? How many days does it rain?
40.
40 out of how many total?
90.
40 out of 90 plus the probability of snow, which is what?
50 out of 90.
50 out of 90 minus the time when they both happen at the same time. When it snows and rains. Minus 10 out of 90. You see how that fits that formula over there?
Mhm.
So what would that be? 80 out of 90. Or 8/9 is probably what they would show in the answer key. Number 16 through 20. Use this table from the department store. Find the probability of having exactly 2 people in line. Number of persons in line is 2. What's the probability? What's it say in that chart? 0.20,
Yeah.
which would be 20 out of 100.
Uh-huh.
Okay? 18. At least one person. Have you figured out when they say at least? At least one person. That means it could be one person, or 2 people, or 3 people, or 4 or more. You follow what I'm doing? So number 18 says at least one person. What's the probability for one person? .15. What's the probability for 2 people in that chart on page 740?
0.20.
0.20. What's the probability for 3? 0.35. What's the probability for 4 or more?
0.20.
0.20. When I add those all together, what do I get? 2, 4, 6.90. So what's the probability of at least one person? 90 out of 100. Or 9 out of 10 times. There'll be at least one person in line. At Walmart, it'll be 100% of the time there'll be at least one person in line. Why do they have all those checkout registers that don't have the lights turned on. They put all those in there just for the holidays.
Mm-hmm.
But normally, there's just about 4 or 5 of them open. So we've all learned to use self-checkout, where we get out of there in a hurry. Number 20. More than 2 people. So now I want more than 2 or what's the other possibility for number 20? Or fewer than 3 or less than 3. So more than 2 would be 3 or 4. Agreed? What's the number for 3?
0.35.
What's the number for 4?
0.20.
Or less than 3. Less than 3 would be what? 2 or 1 or 0. Right?
Well, if it's more than 2 persons or fewer than 3 persons, you're gonna
More
get
than 2
any of
persons
those.
would be 3 or 4.
Yeah.
Less than 3 would be 2 or 1 or 0.
Yeah. So that's all of the possibilities.
So, is that the whole thing? Yeah. So what does that come out to be? 100%?
Mm-hmm.
In solving problems 21 to 25, refer to table 11.4 on page 739. What's table 11.4? Oh, that's that mortality table on page 739. Problem 22. What's the probability that a person who is alive at age 25, how many people are alive at age 25?
89,000.
89,000. And what's it say next? For 22, what's the probability that a person who's alive at age 25 will be alive at age 70?
Mm-hmm.
What's the number alive at age 70? What?
38,600.
38,600. So the probability is 38,600 over 89,000.
Mm-hmm.
Which is about what? 386 over 890. So watch this. That's about 40 over 90. So when you're 25 years old and you're sitting around with a bunch of friends who are all 25 years old, what will you have to say? You know? In, what is that, 35 years? Out of 890 of us, only 386 of us will still be here. Isn't that interesting?
Mm-hmm.
And if you're 70 years old, 38,600. To live another 25 years. To 95. There's only 3 people going to still be here. The other 37,597 are all going to be deceased.
Mm-hmm.
So, from 25 to 70, you've got about a 50-50 chance of living that long. From 70 to 95, you better not be planning on living that long, because it's probably not going to happen. I mean, it will for 3 of them, but for the rest of us, we're all going to be gone. Okay, what's the next one? 24. What's the probability that a person who's alive at age 55 will live 80 more years? What's 55 plus 80?
Over 100.
Yeah. And what does it say?
Nobody lived over
Nobody
100.
lives over 100. So the probability of living at 55 another 80 years would be 0. I don't know why people have trouble coming to grips with mortality tables. They just keep track of how long people live. They read the papers and then build these tables based over time. And does this surprise you that the mortality tables change a little bit from generation to generation?
Mm.
Like the generation that smoked a lot of cigarettes, what do you think? There weren't as many of them that lived as long.
Mm-hmm.
The generation that stopped smoking lived longer.
Mm.
And then the people who stopped smoking, as one guy said, if I don't smoke, I eat too much. So that generation started to eat too much, and the mortality went down again for them.
Mm.
Well, that's just part of the way life plays itself out.
Mm-hmm.
All right, that's enough of mortality stuff. Let's look at some tax stuff.
No, that's worse.
There's 2 things you can be sure of, right? Death and taxes.
Taxes.
So, problems 26 to 30 refer to this table here at the bottom of page 740. And what does it say for problem 26? Find the probability that a form was a long form So I want a long form, or what's the other thing? An incorrectly filled out form. So what's the probability of a long form? There's 2 kinds of long forms. Itemized and not itemized. Or no itemized and itemized. So how many long forms are there? Okay, probability says the total outcome is 100. See that? Where it says the total down there?
Mm-hmm.
So now, how many of those are long forms? 80 out of 100?
Mm-hmm.
Plus incorrectly filled out forms. How many incorrectly filled out forms are there? Over to total. 35, right? But we have to subtract from that the intersection of long forms with incorrectly filled out forms. You see that?
Mm-hmm.
From that formula we had the other day?
Yeah.
So where do long forms and incorrectly filled out forms intersect? Under not itemized is 20 and itemized is 10. So that would be minus 30 over 100. Everybody see that? Or you could say long forms or incorrectly filled out forms. So I go, so long forms would be 60 and 20 is 80. And incorrectly filled out forms that didn't include long forms would be 5. You see how I'm looking at the chart?
Mm-hmm.
So I could say 85. Is that what happens when you do this? Do you get 85? So you can look at the chart and just think your way through what they're talking about, or you can use this formula, whichever one appeals to you. Did that make sense what I just did?
Mm-hmm.
I took the long forms and then it said incorrect, but I don't count the incorrect long forms again.
Mm-hmm.
So I take the 80 plus the 5 over there
Mm-hmm.
under short form. Number 28, find the probability that a form was not filled out incorrectly. If it's not incorrect, then what would that make it?
Correct.
Correct. So what's the probability of correct forms?
65 out of 100.
Okay? And if you took incorrect, not incorrect would be 1 minus incorrect. You see that? So incorrect was what? 35 over 100?
Mm-hmm.
So 100 over 100 minus 35 over 100 equals 65 over 100.
Mm-hmm.
So there's two ways to look at it. It's just a matter of which way makes more sense in your head. And when you start teaching math to those little chippers that you're going to have someday in your life, is it okay to let them see there's more than one way to get to the answer, so they can kind of pick and choose which ones they like best, and maybe even learn to do both of them? Number 30, find the probability the form was a long form with no itemized deductions. Long form with no itemized deductions. That would be 60, except what else did they say? And filled out incorrectly. So what would that be? What?
40?
Is 40 incorrect or 40 correct?
Wait, what'd you say?
Number 30, filled out incorrectly.
Oh, incorrectly. I thought I said correctly.
So what would that be?
20.
20. So 20 out of 100. So read the problem carefully. And stop when you get to 31. Well, maybe we should work 31. The traffic light has a pattern. 60 seconds for green, 5 seconds for red, and 5 seconds for yellow, and 20 seconds for red. I better put those up here. What's green? 60. What's yellow? 5. What's red? Is that right? Did I copy it down right? What's the probability that a driver will find it green or yellow? So what's the total? The total possibilities are 60, 85. Everybody see that? And I want green or yellow, so that would be how much? 65 out of 85.
Mm-hmm.
Green or yellow. So again, that would be 60 over 85 plus 5 over 85 minus 0 over 85 because they don't overlap. And what I want to know is, how does that work for the guys going from the other direction? I don't know how they orchestrate those things. All I know is when I pull up to a traffic light, it seems to see me coming and turns red.
Yeah, well, that doesn't make any sense because even if it's red and yellow for the other cars, that's only 25 seconds.
So while it's 60 seconds green for me, it means it's, what, 60 seconds red for somebody else? But see, they're just saying here, this is a traffic light pattern for me going down 58 highway.
Oh.
The people who are coming from the side, they have a different pattern.
Yep.
Yeah, they sure do. Because while mine is green, that means theirs is probably red, isn't it, for 60?
Mm.
The people on 58 get 60 green and 20 red, and the people coming on to 58 get 60 red and 20 green. So that's why when I pull up to that traffic light to get on to 58, I see a green light, and then just as I get there, it changes to red, and it stays red for a long time because they're giving 58 highway people more seconds of green light. Well, that helps if I understand what they're doing. But I sure wish on some of these intersections that are really like 3 lanes wide, that they would make the yellow light just a little bit longer than 5 seconds. I think sometimes they're only about 3 seconds. I don't know what that's all about. Okay, stop at 31. And this finishes chapter 11. So on Thursday, we'll do the practice test for chapters 10 and 11. But we only cover the first 3 topics of each chapter. And then next Tuesday, a week from today, we'll take a test over chapters 10 and 11. Topics 1, 2, and 3.
I have a question from 11.2.